Class 12th subject Geography chapter is Water Resources. Water, water everywhere, not a drop to drink. It is a very old saying in a different reference to the situation, but this is exactly what we fear will happen very soon. If we do not wisely use and conserve our water resources. Research shows that by 2025, India, along with many other countries, will face a serious scarcity of water. Many regions in our country are currently undergoing the process of water stress. According to a research by Mark, a Swedish expert on water stress happens when the water availability falls below 1000 cubic meters per person per day. Do you think that what exists today will continue to be so? It can be said with some certainty that the society will witness demographic transition, geographical shift of population, technological advancement, degradation of environment and water scarcity. The demographic transition is a model that describes population change over time. It is based on an interpretation begun in 1929 by the American demographer Warren Thompson of the observed changes or transitions in birth and death rate in industrialized societies over the past 200 years or so. Geographical shifts in population. This is a period of a great migratory movements between and within countries. Forward-looking companies and entrepreneurs are taking advantage of the growth in immigrant populations and marketing their wares specially to these new members of the population. The next is technological advancement. Water scarcity is possible to pose the greatest challenge on account of its increased demand coupled with shrinking supplies due to overutilization and pollution. Water is a cyclic resource with abundant supplies on the global. Approximately 71% of the Earth's surface is covered with it, but fresh water constitutes only about 3% of the total water. In fact, a very small proportion of fresh water is effectively available for human use. The availability of fresh water varies over space and time. The tensions and disputes on sharing and control of this scarce resource are becoming contested issues among communities, regions, and states. The assessment, efficient use and conservation of water, therefore, become necessary to ensure development. In this chapter, we shall discuss water resources in India, its geographical distribution, sectors, utilization, and methods of its conservation and management. Water resources of India. India accounts for about 2.45% of the world's surface area, 4% of the world's water resources, and about 16% of the world's population. The total water available from precipitation in the country is in a year is about 4000 cubic kilometer. The availability from surface water and replenishable groundwater is 1869 cubic kilometer. Out of this, only 60% can be put to beneficial uses. The total utilizable water resource in the country is 1122 cubic kilometer. Surface water resources. There are four major sources of surface water. They are river, lakes, ponds and tanks. In India, there are about 10,360 rivers and their tributaries longer than 1.6 km each. The main annual flow in all the river basins in India is estimated to be 1869 cubic kilometer. However, due to topographical, hydrological and other constraints, only 690 cubic kilometer, that is 32% of the available surface water, can be utilized. Children, topography is the study of the land surface in particular area. It lays the underlying foundation of a landscape. For example, topography refers to mountains, valleys, rivers, or craters on the surface. Water flow in a river depends on the size of its catchment area or river basin and rainfall within its catchment area. Rivers in the country like Ganga, the Brahmaputra and the Indus have huge catchment areas. Precipitation is relatively high in the catchment areas of the Ganga, the Brahmaputra and the Barak rivers. These rivers, although account for only about one-third of the total area in the country, have 60% of the total surface water resources. Much of the annual water flow in South Indian rivers like the Godavari, the Krishna and the Kaveri has been harnessed. But it is yet to be done in the Brahmaputra and the Ganga basins. Groundwater resources. The total replenishable groundwater resources in the country are about 432 cubic kilometer. The level of groundwater utilization is relatively high in the river basins lying in the northwestern region and parts of South India. The groundwater utilization is very high in the states of Punjab, Haryana, Rajasthan and Tamil Nadu. States like Chhattisgarh, Odisha, Kerala, etc., which utilize only a small proportion of their groundwater potentials. States like Gujarat, Uttar Pradesh, Bihar, Tripura, and Maharashtra are utilizing their groundwater resources at a moderate rate. If the present trend continues, the demands for water would need the supplies. And such situation will be detrimental to development and can cause social upheaval and disruptions. Lagoons and backwaters. India has a vast coastline and the coast is very indented in some states. Due to this, a number of lagoons and lakes have formed. The states like Kerala, Odisha, and West Bengal have vast surface water resources in these lagoons and lakes. Although water is generally brackish in these water bodies, it is used for fishing and irrigating certain varieties of paddy crops, coconut, etc. Water demand and utilization. India has traditionally been an agrarian economy and about two-thirds of its population have been dependent on agriculture. Development of irrigation to increase agriculture production has been assigned a very high priority in the 5-year plans, and multipurpose river valleys projects like the Bhakra, Nangal, Hirakund, Damodar Valley, Nagarjuna Sagar, Indira Gandhi Canal project, etc. have been taken up. India's water demand at present is dominated by irrigational needs. Agriculture accounts for most of the surface and groundwater utilization. It accounts for 89% of the surface water and 92% of the groundwater utilization. The share of industrial sector is limited to 2% of the surface water utilization and 5% of the groundwater. The share of domestic sector is higher 9% in surface water utilization as compared to the groundwater. The share of agriculture sector in the total water utilization is much higher than other sectors. In future, with development, the shares of industrial and domestic sectors in the country are likely to increase. Demand of water for irrigation. In agriculture, water is mainly used for irrigation. Irrigation is needed because of spatio-temporal variability in rainfall in the country. The large tracts of the country are deficient in rainfall and are drought prone. Northwestern India and Deccan Plateau constitute such areas. Winter and summer seasons are more or less dry in most parts of the country. Hence, it is difficult to practice agriculture without assured irrigation during dry seasons. Even in the areas of ample rainfall like West Bengal and Bihar, breaks in monsoon or its failure creates dry spells. Detrimental for agriculture. Water need of certain crops also makes irrigation necessary. For instance, water requirement of rice, sugarcane, jute, etc. is very high, which can be met only through irrigation. Provisions of irrigation makes multiple cropping possible. It has also been found that irrigated lands have higher agriculture productivity than unirrigated land. High yielding varieties of crops need regular moisture supply, which is made possible only by a developed irrigation systems. This is why that Green Revolution strategy of agriculture development in the country has largely been successful in Punjab, Haryana and western Uttar Pradesh. States like Punjab, Haryana and West Uttar Pradesh are irrigated through wells and tube wells. This shows that these states utilize large proportion of their groundwater potential, which has resulted in groundwater depletion in these states. More than 85% of their net sown area is under irrigation. Wheat and rice are grown mainly with the help of irrigation in these states. Extensive lowering of the water table. This is due to excessive pumping of water from underground, especially in case of wells. When the water is no longer available in the well, it is made still deeper to reach out to the water. But eventually the water seems to be no longer available even in wells. Declination the surface water. When the groundwater gets depleted, the surface water available in lakes and streams also gets considerably depleted. Hence, the water that is available for use becomes very less. Expenses incurred increase. When the groundwater availability decreases, more losses are incurred in terms of finance as the water has to be pumped from a farther and deeper place. In certain cases, the digging of the well even seems to be infeasible too. You can observe in the given image of water level declines. Emerging water problems. The per capita availability of water is dwindling day by day due to increase in population. The available water resources are also getting polluted with industrial, agriculture and domestic influence, and this in turn is further limiting the availability of usable water resources. Deterioration of water quality. Water quality refers to purity of water or water without unwanted foreign substances. Water gets polluted by foreign matters such as microorganisms, chemicals, industrial and other wastes. Such matter deteriorate the quality of water and render it unfit for human use. When toxic substances enter lakes, streams, river, ocean and other water bodies, they get dissolved or lie suspended in water. This results in pollution of water, whereby quality of water deteriorates, affecting aquatic systems. Sometimes these pollutants also seep down and pollute groundwater. The Ganga and the Yamuna are the two highly polluted rivers in the country. Water conservation and management. Since there is a declining availability of fresh water and increasing demand, the need has arisen to conserve and effectively manage this precious life-giving resource for sustainable development. Children, importance to conserve water are to prepare for future droughts, to guard against rising cost and potential conflicts, to preserve the environment, to make water available for recreational purposes, to strengthen communities. India has to take quick steps and make effective policies and laws and adopt effective measures for its conservation. Besides developing water saving technologies and methods, attempts are also to be made to prevent the pollution. There is need to encourage watershed development, rainwater harvesting, water recycling and reuse, and conjunctive use of water for sustaining water supply in long run. Prevention of water pollution. Available water resources are degrading rapidly. The major rivers of the country generally retain better river quality in less densely populated upper stretches in hilly areas. In plains, river water is used intensively for irrigation, drinking, domestic and industrial purposes. The drains carrying agriculture, fertilizers and insecticides, domestic, solid and liquid wastes, industrial effluents join the rivers, especially remains very high during summer season when flow of water is low. The Central Pollution Control Board CPCB was constituted in September 1974 under the Water Prevention and Control of Pollution Act 1974. Further, CPCB was entrusted with the powers and functions under the Air Prevention and Control of Pollution Act 1981. This control board, in collaboration with state pollution control boards, has been monitoring water quality of national aquatic resources at 507 stations. The data obtained from these stations show the organic and bacterial contamination continues to be the main source of pollution in rivers. The Yamuna River is the most polluted river in the country between India and Etwaha. Other severely polluted rivers are the Sabarmati at Ahmedabad, the Gomti at Lucknow, the Kali, the Adhiyar, the Kom entire stretches, the Vaigai at Madurai and the Musi of Hyderabad, and the Ganga at Kanpur and Varanasi. Groundwater pollution has incurred due to high concentrations of heavy toxic metals, fluoride and nitrites at different parts of the country. The legislative provisions such as Water Prevention and Control Act Pollution Act 1974 and Environmental Protection Act 1986 have not been implemented effectively. The result is that in 1997, 251 polluting industries were located along the rivers and lakes. The Water Gas Act 1977, meant to be reduce pollution, has also made marginal impacts. There is a strong need to generate public awareness about importance of water and impacts of water pollution. The public awareness and action can be very effective in reducing the pollutants from agriculture activities, domestic and industrial discharges. Ways to prevent or minimize water pollution. Conserve water. This will result to less amount of water that enters sewage systems, which is a source of contamination. Do not throw chemical substances such as paint, oil, acid, etc. in your sink or toilet. Do not litter in bodies of water, that is ocean, lakes, rivers, etc. Use natural pesticides and fertilizers. The chemical ones seep into groundwater and runs off to bigger water sources, thus polluting the water. Recycle and reuse of water. Another way through which we can improve fresh water availability is by recycle and reuse. Use of water of lesser quality such as reclaimed wastewater would be an attractive option for industries for cooling and firefighting to reduce their water cost. Similarly, in urban areas, water after bathing and washing utensils can be used for gardening. Water used for washing vehicle can also be used for gardening. This would conserve better quality of water for drinking purposes. Currently, recycling of water is practiced on a limited cycle. There is an enormous scope for replenishing water through recycling. Watershed management. Watershed management basically refers to efficient management and conservation of surface and groundwater resources. It involves prevention of runoff and shortage and recharge of groundwater through various methods like percolation, tanks, recharge, wells, etc. In broad sense, watershed management includes conservation, regeneration, and judicious use of all resources. Natural like land, water, plants and animals, and human within a waste watersheds. Its management aims at bringing about balance between natural resources on the one hand and society on the other. The success of watershed development largely depends upon community participation. In the given image, you can see the outline of percolation pond. Watershed. Smaller sub-watershed join to form a larger watershed. And in the next image, you can see example of earthen embankment of percolation tank. The central and state governments have initiated many watershed development and management programs in the country. Some of these are being implemented in the country. Some of these are being implemented by non-governmental organizations also. Haryali is a watershed development project sponsored by the central government which aims at enabling the rural population to conserve water for drinking, irrigation, fisheries and afforestation. The project is being executed by Gram Panchayats with the people's participation. The government of Andhra Pradesh has constituted water conservation mission to focus attention on conservation of water in a big way by taking large scale water conservation measures under Neeru Meeru program, that is Water and You. It was initiated on 1st May 2000. Action plan. An action plan for taking large-scale water conservation work is prepared by the government under Neeru Meeru program which is currently under implementation. The following activities are under execution. Continuous contour trenches, staggered trenches, check dams, rock-fill dams, percolation tanks, gully plugging. Arvari Pani Sansad in Alwar, Rajasthan have taken up construction of various water harvesting structures such as percolation tanks, dug-out ponds, johad, check dams, etc. through people's participation. There is a need to generate awareness regarding benefits of watershed development and management among people in the country, and through this integrated water resources management approach, water availability can be ensured on sustainable basis. Rainwater harvesting. Rainwater is method to capture and store rainwater for various uses. It is also used to recharge groundwater aquifers. It is low cost and eco-friendly technique for preventing every drop of water by guiding the rainwater to borewell pits and wells. Rainwater harvesting increases water availability, checks the declining groundwater table, improves the quality of groundwater through dilution of contaminants like fluoride and nitrates, prevents soil erosion and flooding, and arrests saltwater intrusion in coastal areas if used to recharge aquifers. Rainwater harvesting has been practiced through various methods by different communities in the country for a long time. Traditional rainwater harvesting in rural areas is done by using surface storage bodies like lakes, ponds, irrigation tanks, etc. In the given figure, you can see the image of outline of the irrigation tank. There is a tank supply canal or inlet channel, tank bund, overflow outlet, irrigation canal, tank command area, and downwards you can see tank limit, fields encroaching on the tank bed, and tube wells pumping groundwater. Drainage canal. In Rajasthan, rainwater harvesting structures locally known as kund or tanka, a covered underground tank, are constructed near or in the house or village to store harvested rainwater. There is a wide scope to use rainwater harvesting technique to conserve precious water resource. It can be done by harvesting rainwater on rooftops, also decreases the community dependence on groundwater for domestic use. Bridging the demand supply gap. It can also save energy to pump groundwater as recharge leads to rise in groundwater table. These days, rainwater harvesting is being taken up on massive scale in many states in the country. Urban areas can especially benefit from rainwater harvesting as water demand has already outstripped supply in most of cities and towns. Example of model rural village in India, Raleigh Siddhi, Maharashtra. A good example of a model urban village is Raleigh Siddhi. Some of the major problems in the village were poverty, fragile ecosystem, soil erosion, drought and water shortage, deprivation of food and water. Some of the major steps taken by this village are as follows. Programs such as afforestation and tracing have started being practiced so as to reduce soil erosion in the area. Canals have been built to retain rainwater. Solar power and biogas has been started. Even a windmill has been installed. Water is now available throughout the year due to recent success in watershed management. Solar panels have been installed for every light pole. Voluntary labor was necessary to ensure minimum dependence on the government for financial aids. It socialized the cost of the projects, explained the activities. Even those who were working outside the village contributed to the development by committing a month's salary every year. The World Bank Group has concluded that the village of Raleigh Siddhi was transformed from a highly degraded village ecosystem in a semi-arid region of extreme poverty to one of the richest in the country. The Raleigh Siddhi example, now 25 years old, by demonstrating that it is possible to rebuild Natural capital in partnership with the local economy is a model for the rest of the country. Highlights of India's National Water Policy 2002. In the planning and operation of system, water allocation priorities should be broadly as follows: drinking water, irrigation, hydropower, ecology, agro-industries and non-agriculture industries, navigation and other uses. However, the priorities could be modified or added if warranted by the area region specific consideration. Conservation of water. Efficiency of utilization in all the diverse uses of water should be optimized, and an awareness of water as a scarce resource should be fostered. Conservation consciousness should be promoted through education, regulation, incentives and disincentives. The resources should be conserved and the availability augmented by maximizing retention, eliminating pollution, and minimizing losses. For this, measures like lining in the conveyance system, modernization and rehabilitation of existing systems, recycling and reuse of treated effluents, and techniques like drip and sprinkler may be promoted. Jal Shakti Abhiyan, making water conservation a Jan Andolan. Focus areas: water conservation and rainwater harvesting, renovation of traditional and other water bodies, tanks, reuse bore well recharge structures, intensive afforestation, watershed development. High-level teams constituted in 256 district and technical staff placed in 1592 blocks to take stock of groundwater levels, state of aquifers, ponds and water bodies. This campaign covered both rural and urban areas.